Solve the equation cos of x minus pi over 2 equals sine of x plus pi over 2 for x between 0 and 2 pi radians. Now we have a compound angle here, so we could use a compound angle identity. So this has the form cos of a minus b, where a is x and b is pi over 2. So you can look that up. You'll see that cos a minus b is cos a cos b plus sine a sine b. And we've compound angle identity applied over here. This right hand side has the form sine of a plus b, and if you look that up you'll see that sine of a plus b is sine a cos b plus sine b cos a. Now here we have the cos of pi over 2 radians, or the cos of 90 degrees. That's actually 0. So we get 0 here. The sine of pi over 2 radians is 1. So we have sine of x times 1, which is sine of x. And on the right hand side here we have sine x times the cos of 90. Well, that's 0 as well. And sine of 90 is 1. So 1 times cos x. We actually looked at this identity in a previous video when we were proving or deriving compound angle identity for sine of a plus b. We saw that the sine of any angle minus pi over 2, or sorry, the cos of any angle minus pi over 2 is just the sine of that angle. Now it turns out that the sine of an angle plus pi over 2 is just the cos of that angle. So the equation is simplified considerably down to sine of x equals cos of x. Now let's take this equation and divide both sides of it by cos of x. Now I'm assuming here that cos of x is not 0, because we can't divide anything by 0. I'll come back to the case where cos of x is 0 later on, because we'll have to just take a look at that to see if it's important or relevant. So let's just assume it's not 0 for now. So I've divided both sides of this by cos of x. Sin x over cos of x then will equal cos x divided by cos x, which is 1. But the sine of x divided by the cos of x is the definition of tan of x. So we've reduced our original equation to this equation here, tan of x equals 1. So we're interested in angles whose tan is positive, plus 1 is what we have here. So, well, your calculator will give you one answer. So you can just straight away get the inverse tan of 1 using your calculator. And I'll write down the answer in degrees. In radians, 45 degrees is pi divided by 4. Remember, pi radians is 180 degrees. 180 divided by 4 is 45 degrees. But of course, there is another value of x for which the tan of x is plus 1. And to see that, we go to the unit circle. First of all, indicate the acute angle that your calculator gives you. So we want the tan function to be positive. It's positive in the A quadrant where all the functions are positive, but it's also positive in the T quadrant where only the tan function is positive. So here we're talking about an angle that lies between 180 and 270 degrees. To find that angle, as I've explained before, we just get the image of this point under central symmetry in the origin, and we get the image of this angle under central symmetry in the origin. So we see that this angle here must be 45 degrees. This angle is sometimes called the reference angle. And you can see that to arrive at our answer, we have to add 180 degrees onto 45 degrees. That's 225 degrees. It might be a good idea to check that the tan of 225 degrees is plus 1. Indeed it is. As an aside, the coordinates of this point here on the unit circle, that is a circle of radius 1, are 1 over root 2 comma 1 over root 2. The coordinates of this point down here are given by changing the signs of these coordinates, because we're reflecting this point through the origin. We just change the signs. Now remember that the x value is the cos of the angle, cos 45, and the y value is the sine of the angle. So to get the tan, we put sine over cos. So we divide 1 over root 2 by 1 over root 2, and we get 1, of course. Tan of 45 is 1. But if we divide the y value here by the x value here, we also get 1. So the y value here is the sine of 225. The x value here is the cos of 225. So the tan of 225 is sine 225 divided by cos 225. Minus 1 over root 2 divided by minus 1 over root 2 is plus 1. So we found two values that lie between 0 and 2 pi. Well, I just write 2 pi in degrees for now, 360 degrees. I don't have a problem with radians, it's just that by default calculator settings are often in degrees. You can always convert these to radians. So, as I've explained already, this is easy to figure out. It's pi over 4 radians. Well, to get this angle here, we can just see that 225 is 5 times 45 degrees. We have 1, 2, 3, 4, 5 lots of 45 degrees here if you like. So we have 5 times pi over 4, which is 5 pi over 4 radians. So these are the answers in radians. Now I just want to go back to this equation here and just make sure that we've taken into account the situation where cos of x might be equal to 0, because I divided both sides of this by cos of x, and it had to be not equal to 0, of course. We can't divide by 0. Let's see what happens if cos of x equals 0. Let's see if that gives us any solutions. So if cos of x equals 0, then x is the inverse cos of 0. Now if you go to your calculator, one of the answer you will get will be 90 degrees. So here's the unit circle. Well, I'm not showing the circle, but the point on the unit circle is a distance of 1 to 0, 0. The coordinates of this point are cos 90, sine 90. The cos of 90 is 0, the sine of 90 is 1. Another point whose x coordinate is 0 is here. The coordinates of this point are 0, minus 1. So what angle does this point correspond to? Well, this is actually cos 270, sine 270. This angle here, measured anti-clockwise from the positive x-axis. So another solution to this equation is 270 degrees. Okay, so that's what happens if cos of x is 0, but if cos of x is 0, then sine of x has to be 0 as well. Okay, so if we're putting this equal to 0, then obviously sine of x is 0, and let's solve this. Well, the inverse sine of 0 is actually 0. Another solution is 180 degrees. Okay, again you can get these from you can get this answer from your calculator. The inverse sine of 0 is 0. But 180 degrees you can get from the cast rule, or just draw the unit circle. This point here on the unit circle has coordinates 1, 0. So the cos of 0 is 1, the sine of 0 is 0. That's what we want. We want the sine of 0 to be 0. And we're looking at the y value of this point. But if you go over to this point here, reflect this point through the origin, you'll have a point with coordinates minus 1, 0. Here we're talking about an angle of 180 degrees. So the coordinates of this point are cos 180, sine 180. So you can see that the sine of 180 is also 0. Okay, but you see what happens is we get different values for x here as we get here. See, x is either 90 or 270 here when cos of x is 0. But if sine of x is 0 or 180. So these two angles are different from these two. So you see we get no solutions. when cos of x equals 0. See, one of these numbers would have to be the same as one of these numbers here if we are to get solutions for the situation when cos of x is 0. So there are no solutions for this situation, so we can forget about it. But there are solutions when cos of x is not 0. Namely these solutions here. So you always have to be careful when dividing across an equation by something. Always check, well, you have to state that the thing you're dividing across by is not 0. And then you have to look at the situation for when it might be 0. Here's a very simple example of what I'm talking about. If in this equation here we could divide both sides by x. So we're assuming that x is not 0, of course. X squared divided by x will equal the right hand side divided by x. So divide both sides by x. But x squared divided by x is x, and x divided by x is 1. So here's a solution. X equals 1. It's a solution to this equation. 1 squared equals 1. But we need to look at the situation where x equals 0. See if that leads us to a solution. And indeed it does. If we put 0 in here, we get 0 squared. Put 0 into the right hand side, we get 0. So x equals 0 is another solution. So we might have overlooked this solution if we just simply divided both sides by x and just written this down. This is a solution only when x is not 0. So anyway, in this case, setting x equal to 0 does give us a solution. In the example we did, setting cos x equal to 0 led to no solution. Solve the equation cotan of x minus tan of x equals 0 for x between 0 and 2 pi. Now, you can look up the definition of cotan x. It's 1 over tan of x. Now, we're given here that tan of x is not equal to 0. Well, the reason for that is because we cannot divide by 0. So, the denominator of this fraction cannot equal 0. Division by 0 is undefined. So now, what we can do is multiply this equation by tan of x. Tan of x is never 0, so now we're not going to get 0 equals 0. So if I multiply this fraction by tan of x, I get the tan of x's will cancel. I'll get 1. Tan of x times tan of x is tan squared of x. Tan of x times 0 is 0. So you can see that this equation, by a bit of rearranging, will reduce to a simple trigonometric equation. Tan squared x equals 1. So tan of x can either equal plus 1 or tan of x can equal minus 1, because plus 1 squared is 1 and minus 1 squared is 1. So we take the two square roots of plus 1, positive and negative square roots. The inverse tan of 1 is 45 degrees, and as we've seen in the previous example, there are two solutions to this equation here. X equals 45 degrees or x equals 225 degrees, so I won't go through that again. Now let's solve this one here. Inverse tan of minus 1. Now my calculator gives an answer of minus 45 degrees. So what does that mean? Well, we have to consider the cast rule to make sense of this. So we're interested in the quadrants for which the tan function is negative. So what two quadrants are they? Well, it's the S quadrant and the C quadrant. Now since we got an answer of minus 45 degrees, I'm going to indicate that on this diagram. Now a negative angle, remember, is measured clockwise from the positive x-axis. So this angle here is minus 45 degrees, and as I've explained before, an angle of minus 45 degrees is equivalent to this angle here, which is basically minus 45 plus 360. That's 315. So you could write down either minus 45 or plus 315. These two angles are considered equivalent. Now, we know that there must be another angle in the S quadrant whose tan is -1. To find that angle, we just actually reflect this point through the origin. This is a unit circle. So what angle corresponds to this point here? Well, we're measuring anti-clockwise from the positive x-axis. So it's an angle between 90 and 180. It's in the S quadrant. Well, it's easy to see what the reference angle is. The reference angle is this angle here. So we reflect this angle through the origin. This angle is 45 degrees. So now we can get our angle. We take 45 from 180 and we get 135. And you can check in your calculator, if you get the tan of 135, you'll get -1. Actually, the coordinates of this point here are 1, -1. And the coordinates of this point here are got by changing the signs of these coordinates. So you have -1, +1. It's reflection through the origin. So the cos of 135 is -1, the sine is +1. So tan is sine over cos. 1 divided by -1 is -1. So we divide sine by cos here as well. -1 divided by +1 is also -1. Actually, it's -1 over √2, but that's not too important here. So we're not so much. We can just apply the cast rule. We don't have to worry about the actual coordinates too much. So here are the two solutions. We could of course write -45 down for 3, 115, but actually since we want solutions between 0 and 2 pi radians or 360 degrees, we're interested in positive solutions. So even though these are identical, we ignore the -45 and just use plus 3, 115. So we have 4 solutions to the original equation.